This is the 8.4 guided practice. We are going to be doing the evens, and it is going to be about dilations. The first one, I'm going to do the evens. So the first one, we have to draw the lines of symmetry and state how many. So there's three things we got to do. State whether it has symmetry by writing yes or no. If yes, draw the lines and then state how many. So obviously this number 2 is yes. So then I'm going to draw the lines of symmetry. So pretty much how it can be folded over. So it looks like these are the only two ways. If I try to, say, do it like this, that's not going to be able to fold over. So it looks like just yes and 2. For number 4, I'm looking at that. It looks like, obviously, that's not going to work. So how about we try horizontally? That's a bad arrow, but looks like you can fold it off that way. So it would be yes. I don't see how I can fold it over any other way. So 1. And then 6 doesn't look, because this is, looks like these all have different length sides. So I don't think that would work. It doesn't look to be symmetrical. Can't do this, can't do this. So my final answer for this one would be no. 8, state whether each flag has a line of symmetry, write yes or no. If so, copy the flag, draw all the lines of symmetry, and state their number. So pretty much the same thing we did up top. So looking at number 8, I would write yes. And then just to see how many lines of symmetry there are, it's just like number 2. So there's going to be one that's horizontal. Then there's going to be one like that. I can't go on an angle at all. These two are not going to be able to fold over and be symmetrical. So it looks like it's just yes and 2. All right, number 10. So what we're going to do is determine whether the dilation from figure W to W prime is an enlargement or a reduction. Then find the scale factor of the dilation and x. So we have, this is our original image here. And obviously it gets bigger. So it's going to be an enlargement. Then what we have to do is, we know to find the scale factor, we have to add, or not necessarily add, but we take the bigger number or the length of this, which is 9, and then we divide it by before we can divide it, since we know that this is 9 and this is 4.5, we can assume that this is going to be 4.5. So then what we would do is we would take, 1 second. We would take, 1 second, gotta get my pens right. Since I'm doing this all wrong today. So that's my original image. Obviously things get bigger. So what I need to do is I need to take, if we're going from X to here, I know that it is 4.5. So it gets like 4.5 is the how much it's getting bigger. So I take my 9 and I'm going to divide it by that. So 9 divided by 4.5 is going to be 2. So the scale factor is 2. So then if I take 2 times my x, it will give me, and I'm sorry, not not 2 times my x, but if I take 9 minus my 4.5, I get 4.5. And that's my final answer there. Let's try number 12. All right, so this looks to be like our original right here. It goes all the way around. And so it's going to get smaller, so which means it's a reduction. So then our scale factor, just so we have this, is the image divided by the pre-image. So that's what our scale factor, or K, is going to represent. So if the entire image, or I'm sorry, if the entire image is 14, because that's the length of this whole section right here, and then our image is 10.5, I would do 14 divided by 10.5. If I do 14 divided by 10.5, I get 1.3 repeating. So I would round that to 1.4. And then what is my x? Well, you can find your x by taking 14 minus the 10.5. So, oh, and I did that wrong. Sorry about that. I feel like it's Monday morning. So it's 14 divided by 10.5. So 14 divided by 10.5. Oh, I did that right. I just didn't write it down. So it's still 1.3 repeating, so scale factor here is right. And then to find x, all I need to do is take, erase this so you guys can see it. I'm going to take the entire thing, which is 14. That's my whole image. I'm going to do 14 minus 10.5. And that's going to give me this section right here, which is x. So that will be 3.5. All right, so it says find the image of each polygon with the given vertices after a dilation centered at the origin with the given scale factor. So we have the pre-image. Now we need to find the image. So if I plot the points, which I'm going to do. So after I plotted my points and I get my figure, then I go to the scale factor, which is K here. It's 1.25. So since it's above 1, it's going to get bigger. So just like going back here, is it an enlargement or a reduction? It is an enlargement. So we can expect this figure right here to get bigger. So then S prime would be, we're taking this and we're multiplying it by these here. So S prime is still going to be 0, 0, okay? But then T prime is going to be -4 times 1.25. So that's going to be a -5. And then a 0, and then V prime is going to be -8 times 1.25, and then so that'll be -10, -10. So now I'll just plot my points quick, and as you can see, after I plotted those points and in the red, it did get bigger from the point of origin, which was S right here, so that's the reason why that didn't move. So let's go on to 16. So first off, K is 2.5. So it's going to be an enlargement. So then what I need to do is first plot my original points. And I'm going to do that right away. So I have my pre-image ready to go. Now I got to find my image. So all I'm going to do again is multiply these right here. So M prime is going to be 2 times 2.5 is going to, negative 2 times 2.5 is going to be negative 5, and then 0 times 2.5 is 0. P prime is going to be 0, and then 2 times 2.5 is 5. Q is going to be 2 times 2.5 is 5. 0, and then finally R, that's a negative 2 in there. R prime is going to be 0, negative 5. So I'll plot these points real quick. And after plotting them, it gets 2.5 times bigger. So you are left with what it looks like here. And then let's just make sure we're answering all the questions. And it looks like it is. It just says find the image. So we're finding the image in all of these. All right, that's it. If you have any questions, let me know. Otherwise, have a good night.